You know that little blue dot on your phone? The one that seems to know exactly where you are every single second? It feels like magic, right? Well, today we're going to pull back the curtain and see exactly how that everyday magic actually works. Let's get right into it. Right, so that's the big mystery we're tackling. How on earth does that little dot pinpoint you with such mind-boggling accuracy? I mean, whether you're driving, biking, or just walking down the street, it's right there with you. It's time to solve this thing, and believe it or not, it's kind of like a cosmic detective story. So our investigation starts way up, thousands of kilometers above our heads. We're going to look at a huge network of, let's call them witnesses in the sky. So yeah, today we use it to find the nearest coffee shop or track our morning run. But here's a fun fact. GPS wasn't invented for that at all. It actually started as a U.S. Department of Defense project. This whole global positioning system, or GPS as we all know it, was originally a military thing. It only became fully operational and available for you and me to use back in 1995. So how many of these witnesses are we talking about? Well, there are over 30 of them. Yeah, more than 30 active satellites. This isn't just one or two little spies in the sky. We're talking about a whole constellation of them, constantly moving, perfectly coordinated, and working 24/7. And get this, these things are operating on a whole other level. They're orbiting at a mind-boggling 20,200 kilometers up. To put that in perspective, that's high enough to circle the entire planet twice a day. The whole system is designed so that no matter where you are on Earth, at any given moment, you can see at least 4 of these satellites. And remember that number, 4. It is absolutely crucial. Okay, so we've got our witnesses. Now for the next part of the investigation, the clues. We need to look at what these satellites are actually sending down to us. And these clues, they're totally invisible and they travel at the fastest speed in the universe. Every single satellite is constantly beaming out a radio signal. You can think of it like a constant little ping, and in that ping is everything we need. It's basically saying, hey, I'm this specific satellite, this is my exact location in space right now, and the time is precisely this. That's it. Those 2 little bits of info, where the satellite is and what time it sent the signal, are the fundamental clues to everything. All right, so your phone grabs that signal. Now here's the brilliant part. Your phone knows one really important thing. The speed of light doesn't change. So it does some super simple math. It looks at the time the signal was sent, looks at the time it was received, and measures that tiny delay. And with that, it can calculate exactly how far away that satellite is. Simple, right? But when I say tiny delay, I mean unbelievably tiny. This is where precision becomes everything. Look at this. A timing error of just 1 microsecond, that's 1/millionth of a second, and your location is off by 300 meters. That's like 3 football fields. This is exactly why every GPS satellite has an atomic clock on board, one of the most accurate timekeeping devices ever invented. And get this, they're so sensitive they actually have to account for Einstein's theory of relativity. Seriously, because they're moving so fast and are in weaker gravity, their clocks literally tick a tiny bit faster than ours here on Earth. If scientists didn't correct for that, the whole GPS system would be off by kilometers every single day. Just wild. Okay, so we've got the witnesses, we've got the clues, and now it's time for the big reveal. This is the moment it all comes together. This is how your phone takes all that info and makes the brilliant deduction to find you. This whole process is called trilateration, and it's pure genius. Let's walk through it step by step. So, a signal from one satellite tells your phone, okay, you are somewhere on the surface of this giant sphere. It's a huge area, but it's a start. Now, a second satellite chimes in. See how the 2 spheres cross? That intersection narrows your location down to a perfect circle. We're getting closer. Then a third satellite joins the party. Its sphere cuts that circle at just 2 possible points. And now for that 4th satellite. Remember the magic number? It's the ultimate tiebreaker. It confirms which of those 2 spots is you, and, just as importantly, it helps correct for any tiny timing errors in your phone's clock, which, let's be honest, is nowhere near as good as an atomic clock. And there you have it. That's the key takeaway. 4 is the magic number. Your phone needs to see at least 4 satellites to lock in a precise 3D position. That's your latitude, your longitude, and even your altitude. And that is the secret behind that little blue dot. All right, so we've solved the cosmic part of the mystery. But let's bring it all back down to Earth. How does this all play out in the real world, inside the phone that's sitting in your hand right now? Because, in the real world, things aren't always perfect. If you're out in the open with a clear view of the sky, your phone's GPS is ridiculously accurate. down to about 5 meters. But what about when you're in a big city, surrounded by skyscrapers? Those signals can bounce off buildings, creating something called an urban canyon effect. That can mess things up, pushing the accuracy down to 20 meters or even more. And if you go indoors, forget it. Those satellite signals just can't get through the roof, and you'll likely have no signal at all. So wait a minute, if it doesn't work well indoors, how does your phone sometimes find you so fast even inside? Well, it kind of cheats. It uses something called assisted GPS, or AGPS. This means your phone isn't only listening for satellites. It's also using cell phone towers and Wi-Fi networks to get a quick, rough idea of where you are. This makes that initial location lock way, way faster, and it's why it can sometimes get a decent fix even when you're inside. And here's another cool thing. It's not just about the American GPS system anymore. Your modern smartphone is basically a global citizen. It's not just listening to the US satellites, it's also listening to Russia's GLONASS system, the European Union's Galileo, and China's Beidou system, all at the same time. The more satellites your phone can see, no matter whose they are, the more accurate your location is going to be. So why should you care about any of this technical stuff? Well, because this incredible, complex dance between satellites and signals and timing, it pretty much powers our entire modern world. We're talking about the turn-by-turn navigation that gets you where you're going, the ride-sharing apps you use, the way you track your workouts, even logistics and shipping, and, most importantly, making sure emergency services can find you in a crisis. It's truly the invisible backbone of our day-to-day lives. So there you have it. The case of the mysterious blue dot is officially closed. It's pretty amazing when you think about it, right? A system that was born out of military needs is now the thing that guides us to the best pizza place in town. What a journey. But it does leave you with a final, big question to ponder. Now that we have this unbelievable power to pinpoint literally anything, anywhere on the planet, what do you think we're going to track next?